Okay, in the last video we looked at generating the Maclaurin series for e to the x. In this video I want to talk about using this table of Maclaurin series. Now you can use this formula up here to generate all the stuff that's in this table. This formula tells you the coefficient of x to the n. And these get used a lot. And so what I want you to be able to do is use this table to come up with Maclaurin series for other functions. Before we do that though, it's kind of interesting to look at this. If you look at the series for e to the x, if you take the derivative of this, it'll wind up giving you back exactly the same series, which is of course what you'd expect for e to the x. If you take the derivative of the function for sine x, it's going to give you the one for cosine. And we can see that by just playing with a few of them. Derivative of x is 1. Derivative of this term would be minus 3x squared over 3 factorial. Well, that would cancel and give you minus x squared over 2 factorial, which is exactly what this term is. And it would continue. And of course, if you took the derivative of the cosine series, it'd give you the negative of the sine series. So anyway, these do all the stuff like that you would expect. But let's look at how to use these series to come up with other things. So right here, let's say we want to find the Maclaurin series for f of x equals x sine x. Well, I'm going to come up here and grab the series for sine. I'm going to copy it down here because that's what we need to answer this question. Okay, the Maclaurin series for sine is this. And so if we want x times sine x, really all that's going to do is take this and put another x in here. So I'm going to have to multiply this by x. And then I'm going to have to multiply everything over here by x. So in the sigma notation, we got 0 to infinity, negative 1. This would be x to the 2n plus 2. And if we wanted to write out a bunch of the terms, we're just going to distribute this x inside of there. So you get x squared minus x to the 4th over 3 factorial plus x to the 6th over 5 factorial minus x to the 8th over 7 factorial, like that. So there's not really a whole lot to it. It's really just multiplying the whole thing by x. Now this next example, sine of x cubed, this one's a little more involved, but not much. So what we're going to do is take the original series for sine x, and we're going to replace each x with x cubed. So I want to write this two ways. I want to write it using the sigma notation, and I also want to write this bit over here. So for the sigma notation, we're just going to take this and do negative 1 to the n. This will be x cubed to the 2n plus 1. And so, I mean, technically we're done at that point. You could distribute this 3 across there and get 6n plus 3 instead of 2n plus 1, but really that'll do it right there. If I gave you this problem, I'd probably ask you to write out the first several terms. So let's see. Basically here we'd replace each one of those x's with an x cubed. So this first term is going to become x cubed. Then x cubed cubed. Now I wouldn't want to leave it like this. I would want to rewrite that as x cubed minus, remember when you get a power to a power, you multiply the powers. So you got x to the 9 over 3 factorial, x to the 15 over 5 factorial, x to the 21 over 7 factorial, like that. So the answers to this would be these two guys. All right. Next example really is very similar to the one we just did, only this time we need to grab the thing for e to the 3x, or e to the x. So let's see, e to the x is this thing. All right, so if I wanted to find the series for e to the 3x, I'm just going to replace each one of these x's with a 3x. So this is going to be n factorial under 3x to the n power. And on this side, we're going to get 1 plus, this will be x, or not x, it'll be 3x over 1 factorial. Next one will be, I could put it in 3x and then quantity square it, but let's go ahead and write that out as 9x squared. Next one will be 3x quantity cubed, so 3 cubed x cubed. Then one more 3x to the 4th. That's going to be 81x to the 4th. Over 4 factorial plus dot dot dot. That's really all there is to it.